Welcome to Train Signal. I'm Ross Bagurtis, and in this video, I'll be discussing access control list basics. Now, an access control list is used on a piece of network gear in order to select and typically filter traffic that goes through that particular device. When we do this with an access control list, we're really focusing on only two layers of the OSI model, the transport layer and the network layer. At the transport layer, we're going to be able to write a access control list that can filter based on TCP or UDP protocols, and then it can also filter based on the port number at the transport layer, either the source port number or the destination port number. At the network layer, we're going to use IP addressing, and we'll be able to use an access control list to filter with the IP protocol and a source and destination IP address. Now, generally speaking, we have two types of access control lists. Now, this is actually very specific to Cisco equipment. However, the same general concept applies to other equipment as well. Now, we have a standard access control list. We don't use standard access control lists very often because they are only able to select traffic based on the source IP address only. So we can only examine the source IP address of a packet in order to determine whether to filter that or not. Now, this is mainly used for selecting traffic versus filtering traffic on an interface. And what we use for selecting traffic is we may select the traffic to use in some other process. Now, an extended access list will select packets and segments based on a source and destination IP address, or the TCP or UDP protocol, or transport layer source port or destination port numbers. Now, here's where we can filter on nearly every piece of critical information in a packet and segment. We can filter on the network layer information, source and destination IP address. We can filter on the transport layer information, TCP or UDP, and then the source and destination port number. Here's really where we use these in setting up firewalls or setting up filters to apply to an interface of a router in order to restrict traffic. In this demonstration, we're going to primarily be focusing on the extended access control list. To configure these lists, on a Cisco router, what we would do is at the config mode prompt, we would type in the command IP access list standard if we wanted a standard ACL, and then we'd give it a name. After that, it will bring us to a new prompt, and the new prompt that it brings us to here says std-nacl, which is standard named access control list. Here we can say permit or deny. I've put that in brackets where we have to choose one or the other. And then in the greater than and less than sign, we need a source IP address, and this is something that we actually have to type in. It's a variable. And then a wildcard mask, which is a variable. If you're unfamiliar with a wildcard mask, the concept of it is very basic. It is simply the inverse of a subnet mask. So if I have a subnet mask of 255.255.255.0, my wildcard mask is 0.0.0.255. If you think about it in the binary sense, in binary we have a string of ones followed by a string of zeros. That is a subnet mask. If we take where the ones are and we put zeros, and where the zeros are we put ones, that returns a wildcard mask as well. So the wildcard mask is just the inverse of a subnet mask. An extended access list, on the other hand, now we can use the command IP access list extended and then a name. And here we're going to say permit or deny. We're going to choose a protocol, either IP, TCP, or UDP. There are other options here, but for the purposes of this conversation, we are primarily going to be filtering based on these protocols. We can specify a source IP address plus its wildcard mask. If we want to specify a source port number, we can do that by saying EQ and then the source port number. We can then specify a destination IP address and its wildcard mask, as well as a destination port number. Now, these two lists that I've shown you here are for named access lists. And since the Cisco operating system, iOS, came out with these named access lists, I've personally preferred to use the named version of these lists versus the numbered version of the lists. The numbered version of the list is very nice, gives you a number to associate with a type of access control list. However, you have to translate the number into some description. When we're using the named access control lists, it's a lot easier because we can give the name of our access list something very, very specific so we know exactly what the purpose of that ACL is. So I tend to stick with the named ACLs here. Now, let's think about where we would apply access control lists. Now, I've already mentioned that we can use it to filter traffic coming in and out of an interface. The idea here is that we write an access control list, and that access control list is a tool on the network gear that will actually select traffic. Then what we can do is we can actually apply it to an interface in an inbound or outbound direction. And then now that access control list that selects traffic will take of action of either allowing traffic through the router or blocking traffic into the router. So that's one application of an access control list. Another one is that we can use it to select traffic to be used in some other process. This would be like NAT or policy-based routing. NAT is network address translation, and on Cisco devices, as in many other devices, we need to make sure that we have an access control list that dictates to the network device which traffic should be put into the network address translation process and which traffic should be ignored from the process. Last, we can also use this to restrict Telnet and SSH access via the VTY ports. So we can actually create an access list and apply it to the VTY ports to restrict access on there as well. So let's use this now to create a scenario that we can set up some access control lists. Now, GlobalMantix is our organization here, and they're setting up a small DMZ for web and TFTP traffic. Now, what a DMZ is an area of the network designed to limit traffic to servers or other devices in there. So only the minimum required services are accessible. And what this means is if we have a web server in our DMZ area of our network, we want to make sure that we only allow web traffic to the web server and not any traffic to the web server. This way we can protect our web server from receiving traffic that was never destined for it. We can actually block that with our access control list. And what this does, it prevents access to the servers with services that may not be desirable. So really what we're trying to do is we're trying to stop somebody from coming into our network and try to attach to our server on SSH or some other port that we don't want them to. So let's set up our scenario here. So we have our GlobalMantix network, and we have the DMZ area here, and that's outlined in this blue box. And the network that it's on is 10.128.50.0/24. We have a server up here with a .1 IP address, and we don't know what that does, and it's not important. We have another server here, .201, that's the TFTP and DNS server. Then we have a third server down at the bottom here, that is our web server, which is at .202. And that hosts www.globalmantix.com. Our router interface over here, F00, has an IP address of 10.128.50.254. On the other side of the router, we have essentially the rest of the world, and this is going to be my workstation that we're watching in this video. I will occasionally remote desktop to these other devices in here so you can see what's happening on the other device, but ultimately this instructor workstation is going to represent the entire internet or the whole world from outside. And that network is 192.168.10.0/24, and my workstation is .10, and the router's interface is .1, and that's on the F0/1 side of the router. Now I said the purpose of a DMZ is really to limit traffic in and out. So let's think about our requirements, and I've really predefined some of these. So what we want to do is we want to deny all traffic from the 192.168.10.0 network to the 10.128.50.1 IP address. And there may be good reasons for this. There may be sensitive information on here. Or it may be a server that we're just not ready to bring online yet, so we want to deny access to that particular device. So we're going to block all traffic from that. There's no real good reason other than we're going to set it up so that we can have a somewhat sophisticated access control list to take a look at. Second, since my instructor workstation here is personal to me and I'm an administrator, I want to be able to send information to the TFTP server and back again. So I'm going to only allow TFTP traffic from my IP address 192.168.10.10 to the TFTP server at 10.128.50.201. And then last, I'm going to allow only HTTP traffic from 192.168.10.0/24 to my web server. So I'm only going to allow web traffic to that server. So these would be just basic requirements that we would use to set up in a DMZ like this. We're really just restricting what traffic is allowed to the web server, to the TFTP server, and to this top server over here that is top secret right now. So let's take a look at how we take these requirements then and then translate it into an access control list. One of the things we're going to have to be very aware of when we're writing this access control list is the direction the traffic is flowing as we're filtering it. Now, since we really want to restrict most of our access to these servers in the DMZ, we're actually going to put an outbound access list on this interface. We're going to filter traffic as it enters the DMZ. So the inbound traffic into the DMZ is actually the outbound traffic from Fast Ethernet 00. So we want to filter traffic as it leaves Fast Ethernet 00. So what this means is that the 192.168.10.0 network, that's going to be our source network, and our destination network is going to be the 10.128.50.0. And this is something we always want to be aware of when we're writing access control lists is direction, because the direction of the packet moving through the network and through the access control list is critical to making it work correctly. So let's take a look at how I set this up. Now I have a very easy setup method that I use for this, and essentially what I do is I create a table, and my table has all of the different variables that are allowed in an extended access list. So I have permit and deny, I have the protocol that I want to filter on, the source address, the destination address, source port number, destination port number. And then what I do is I look at my requirements and I just fill in the blanks, basically. So for my first requirement, I want to deny all traffic from 192.168.10.0/24 to 10.128.50.1. So permit deny, I want to deny that traffic. The protocol is IP here. We're not concerned about a port number or any transport layer information. My source IP address is 192.168.10.0/24. My destination IP address 10.128.50.1, and since I'm not using TCP or UDP, I may not specify source and destination ports. Next requirement, allow only TFTP traffic from 192.168.10.10 to 10.128.50.201. So here I want a permit statement. I'm going to have UDP as my protocol, my source address 192.168.10.10, which is my workstation, to the destination address of my TFTP server. Source port I don't care about, and I know that TFTP operates on port 69. So, and I remember too that TFTP is one of the few protocols that actually uses UDP at the transport layer. So in order for us to filter the TFTP traffic, we have to remember that TFTP at the application layer uses UDP at the transport layer. And because of that, our access control list is going to have to filter based on UDP. Last, we have this requirement that we need to allow only HTTP traffic from 192.168.10.0/24 to our web server at 10.128.50.202. This time we're going to permit it again. However, we'll use TCP as the protocol here because HTTP at the application layer always makes use of TCP at the transport layer. We put in the source address range of 192.168.10.0/24. We have our destination of 10.128.50.202. Source port number doesn't matter. Port 80 is our destination. Now, something that's very important to remember here is that access lists are applied in the order that they are configured. And as a packet comes into a device and is filtered by an access control list, the packet is compared to each line of the list in order of the list. Once the packet finds a match, it takes the appropriate action, either permit or deny, and then the process of inspecting it against the access control list stops. Because of this, every single access control list has an implicit deny any at the end of the access control list. And what this does is it allows that if we accidentally put a bunch of permit statements in our access control list, and if the last line is permit any implicitly, that means that our access control list won't actually do anything at all. It'll allow all the traffic through. So what we've done is Cisco has done this on their devices. They've applied this implicit deny any rule. And what that says is that any traffic that doesn't match one of these rules in the list will automatically be denied anyway. So we have to pay attention to the order that our list is written, because if we write a rule after another rule that contradicts it, it will not work. So for example, if I wanted, I could say, let's make sure that 192.168.10.10 cannot access the web server at 10.128.50.202. So if what I did is after this line here, permit TCP 192.168.10.0, I added in another line there that says deny TCP 192.168.10.10 to the destination of my web server here on port 80. But what happened is that rule would never get hit, because I would come to this rule where it permits any traffic from the entire network 192.168.10.0 that would be allowed through to port 80 on my web server. The next line would never get hit with that traffic because my IP address 192.168.10.10 is inside of that network. So the order that I write these lists in is very important, and the fact that implicit deny any is at the end is always something that you need to be very aware of. We can actually break networks when we do this. So let's actually go on now. Now that we have this list written, and it is written relatively correctly, and I say relatively correctly because I'm actually setting this up to fail so that we have something to troubleshoot later. And it's going to fail in a couple aspects. And we're going to use Wireshark and some other utilities later on to troubleshoot exactly why this is problematic. But we're actually going to see that we can get some of this to work properly. Let's see what we can get it to work. So let's go ahead in the next step and actually write the access list. So we're going to take the information that I put into this chart here, and we're going to now use that to fill in the blanks of our extended access list. So I've put the syntax down here. We're going to do IP access list extended. And I'm going to call this DMZ inbound, because remember earlier I said we want to filter the traffic as it comes into the DMZ network. And in order to do that, we need to put an access control list on F00 in the outbound direction. So here what I've done is I've taken my first rule, and after I've set up my extended access list name, it brings me to my new prompt, and I say deny. The protocol is IP. My source address 192.168.10.0. Remember, I have to use that wildcard mask, which is just the inverse of my subnet mask. Since here it was a 24-bit subnet mask, or 255.255.255.0, my wildcard mask ends up being 0.0.0.255. 10.128.50.1 is my destination. And my wildcard mask here is 0.0.0.0, which means that I want to leave all of the bits. I want to match all of the bits in that IP address. So really when you use 0.0.0.0, it means for a single host. So that meets my requirements for this first line. Next, I want to permit UDP traffic from the 192.168.10.10 to the destination of 10.128.50.201 with a destination port of 69. And so my access list then is permit UDP 192.168.10.10, this time with a host wildcard mask of 0.0.0.0, and then my destination 10.128.50.201, again with a host mask of 0.0.0.0. A host wildcard mask is 4 zeros like this. And that's going to be equal to port 69 in the destination port field. So the destination port number will be 69 for this. Last, I want to permit TCP traffic to my web server from the entire 192.168.10.0 network to the web server's IP address on port 80. And that's the last line here, permit TCP 192.168.10.0. This time we want the entire subnet, so we do 0.0.0.255 to the IP address of my web server using that host-based wildcard mask again of 0.0.0.0. This time the destination port needs to be equal to 80. So let's go apply this access control list now to our router and see what problems occur. Now I've already set up an access control list on here that mirrors the one that we discussed in the PowerPoint presentation. So if I do show access list, it's going to show me what I've configured. I have had to add one line to this access list in order to get the demonstration to work correctly. And what I need to do is I need the ability to remote desktop to those servers over there on the other side of the network in the DMZ. And in order to do that, I have to allow port 3389. So my first list of my access control list here is one that I had to actually hack in here to get the demonstration to work nicely, and that is permit TCP host 192.168.10.10 to anything on the 10.128.50.0 network with a destination port number of 3389. And 3389 is the port number that remote desktop connection uses. So that's going to allow me to show you the desktop of the other servers in the DMZ while we're troubleshooting and testing this access control list. So the rest of the access control list is identical to what I showed you earlier. What's not shown here is that implicit deny any, and that's because it is implicit. So before we go ahead and turn this access list on, what I want to do actually is test to see which services are currently working and that we can actually reach all the services through our router right now before we start to block them. One of the things that we oftentimes do with an access control list is we'll implement it, and before we implement it, what we fail to do before we implement it is we fail to test to see if the service that we're filtering actually works without a filter. So what I'm trying to get at here is we're going to test our web server to make sure we can get to our web server. We're going to test our TFTP server to make sure we can get to that. We're going to test to make sure that we can ping all the IP addresses on everything on that network. So let's do that first. I'm going to open up a command prompt. And there's 3 IP addresses we should be able to ping right now, because even though I have this access list configured on my router, I do not have it applied to the interface right now. So it's just sitting there idle. So let's ping 10.128.50.1, and we get a reply from there. And this was one of the requirements that we had, that we did not want to get a reply from that device. If we ping 10.128.50.201, in this case, we only wanted to have one device access TFTP on that server, yet ping is allowed, and that also violates our request. Last, ping 10.128.50.202, our web server. Here, once again, we should only have web services available here. ICMP should not be allowed to respond to that ping. Let's check our web services. So first, I'm going to go to www.globalmantix, oops, spelled that wrong, globalmantix.com, and I've set up this very simple text-based website so we can do other troubleshooting and investigation of Wireshark. So we have this very basic text website for GlobalMantix, so we know that that's up and working. If I clear that out and go directly to the IP address 10.128.50.202 and test that, that also works. So now what I want to do is clear my web browser history. Clear that browsing data and close that window. Last, let's check TFTP. So far I've checked to see if I can ping everything, and I can. I checked web services, those work. Let's check TFTP services. To do that, what I want to do is first open up remote desktop connection to my TFTP server. So I want to take a look at what our TFTP server is set up to do here. So here's a TFTP server itself. It's just a little application I have running on another workstation in my network. And then here's the folder TFTP root where the files are stored. Now we usually are using TFTP to transfer some type of iOS image, which is the operating system image on a router, on a Cisco router specifically. So it's typically what we're using TFTP for. We sometimes use it to transfer configuration files as well. So I have this set up to have this simple 3 meg iOS image file here on my TFTP server. Let's see if we can copy it from the TFTP server down to my workstation. To do that, I need to open Command Prompt again, and I will use the TFTP utility on here. To do that, I type TFTP. The first piece of information I type in is the TFTP server's IP address, which is 10.128.50.201. Then I have to tell TFTP, do I want to get a file from the TFTP server, or do I want to put a file on the TFTP server? And in this case, I want to get the file from the TFTP server, and then I put the file name. That file is called iosimage.bin. Then next, I put the place where I want to save the file. Here I want to save it in my c:/TFTP directory, and I'm going to call it iosv1.bin. And what that should do is it should connect with the TFTP server, and it will start the transfer to my workstation. TFTP is a very slow application. It actually looks like it's almost failing here. Let's take a look on our TFTP server and see what's happening. There it is. So there's our bar. It was just hidden behind our file browser window. So we're actually transferring the file now that should be on our workstation soon. So let me browse to my TFTP directory and see that iosimage.v1.bin is in my directory now. So I transferred it from the TFTP server down to my workstation using the TFTP protocol, and we can see that it was successful. So the services that we need to access in our DMZ are functional. So the next step would be to now go to our router and actually apply our access control list. So to do that, I'll go into configuration mode. I will browse to interface fast Ethernet 00 and use the command IP access group, the name of my access control list, inbound, and then the inbound or outbound direction. Now, since this is the access control list that's filtering traffic as it leaves the router and goes into the DMZ, we want an outbound access list here. So we want to say IP access group out because we want to filter the traffic as it leaves fast Ethernet 00 and goes into the DMZ. Next step, retest. So let's, first things first, let's test to see if we can access globalmantics.com. So I'll browse to www.globalmantics.com. And the website comes up. Now, I know that this should not happen. And the reason I know this should happen is that we are denying our DNS queries. And our DNS server is out there in the DMZ. So let's double check this, because what I'd expect to see is if we went to a different website, we would not actually be able to browse to that site. So let's do something first. Let me clear my DNS cache. And the way I clear my DNS cache is I issue the command ipconfig/flush DNS. And what this will do is it'll take any DNS resolved host names on my workstation that have been resolved and saved. It'll take those and flush them away so that we automatically get new information. Now, our workstation will do this flushing for us automatically every few minutes. We just didn't hit that threshold of it being cleared. So let's go back now to Chrome, and I actually want to clear my browsing history again, just to be sure. Close that file. open it back up again, and now we'll go to www.globomantics.com. And now what we should see is that now that we do not have a locally cached resolution for www.globomantics.com into an IP address, we should not be able to get to that website anymore. And that's exactly what happened. If we try to go to the IP address directly via the IP address, the website works just fine. So what I've done here is I've actually both inadvertently and intentionally created this problem where we broke DNS in our DMZ with our access control list. This is something that happens a lot, where we accidentally forget that we have to allow this DNS protocol through to make our application work. And in a later video where we do some troubleshooting with Wireshark and access control lists, what we're actually going to do is we're going to watch this process happen in Wireshark and troubleshoot the problem and then modify our access control list to make it work. So I really have intentionally set this ACL up for failure with a very common failure so that we can later on go troubleshoot it and see how to fix it. So what we've seen here is that my website works, but I cannot use DNS to resolve my hostname into the website, and that is problematic. My last thing here is let's try out, actually it's not my last thing, we have a couple more things to do here. Let's test our pings first before we test TFTP. So let's see if we can ping to each of our addresses. And what we should expect is we should expect to get denied from ping from all of our addresses by that implicit deny any at the end of our access control list. So I'll do ping.10.128.50.1. And we should already see a response, and we don't. We see request timed out. See a second request timed out. I most likely cannot get there. Sending more requests to that IP address probably will not result in a successful ping. If I do to my TFTP server, send a ping there. Once again, this isn't looking promising. It looks like my ping is failing. The first one failed. The second one failed. So we definitely do not have ping connectivity to my second IP address there, which is a TFTP server, which is also expected behavior. So ping 10.128.50.202, my web server. Here, once again, I'm not getting a ping response from that server, which is the exact behavior that we wanted. So far, with our access list, we have one win in that we actually successfully filtered our traffic so that anything on the 192.168.10.0 network can access the web server at 10.128.50.202. However, we can only do it if we browse to it via the IP address. Our TFTP connection now, let's give that a try. So what we're going to do is I'll open up my folder here with TFTP in it. And right now I have that one file, iOS image v1.bin. We're just going to transfer that file again. I'll just call it v2 this time. And what we want to do is here on my remote desktop connection to my TFTP server, I want to watch what happens when I try to make this file transfer. So TFTP 10.128.50.201. I want to get a file that is called iOS image.bin, and I'm going to store that locally as the file called iOS image.bin, iOS_v2.bin. And let's see what happens here. We see a connection on my TFTP server, and it looks like it's beginning to transfer the file. But let's see what happens. It looks like it's asking again. It looks like it's asking yet a second time now to transfer the file. And we can see here it's not making any progress. So it appears that something is wrong here, and TFTP is not working. And if we look at our local workstation here, it says error on server, undefined error code. So it doesn't know what's going on. So, and if we look in our file here, we did not transfer the file. Something is wrong with our access control list. And now, even though UDP access list that we wrote for TFTP on port 69, even though we set that up to be on TFTP's port, It appears that some traffic is getting to our TFTP server, but not all of it. So what we'll have to do is we'll actually have to use Wireshark once again to troubleshoot and find out what's happening with TFTP to cause this problem not to work. It worked before we applied the access list. After we applied the access list, it stopped working. So we'll use that methodology then to go figure out why it broke. In troubleshooting access control lists for TFTP and DNS, we're going to take a look at how we can actually use Wireshark to troubleshoot and fix these issues. That concludes this video. I look forward to seeing you in future videos. Thank you.